Is on stoichiometry, which is the study of chemical quantities in a reaction.
Go.
Some review terms you need to remember for stoichiometry are mole ratio and molar mass. Mole ratio is the ratio of moles of one substance to the moles of another substance in a balanced equation. For example, there are 2 moles of H2O for every 1 mole of methane. Molar mass is the mass of a given substance, and it should always be in grams. So the molar mass of water, which is found on your periodic table, is 18.016 grams. Convert from the mass of one substance to the mass of another, first you have to convert substance A to moles. And you do this by dividing by the molar mass of the substance that's found on the periodic table. Second, you need to find the mole ratio between the two substances by using the coefficients from the balanced equation. And lastly, you need to convert the moles of substance B into grams, again using your molar mass from the periodic table.
Go.
Okay, so for your first example problem, we need to find the mass of water that's produced by burning 500 grams of methane. Methane is CH4. So your first step is to take your grams of methane. So we put 500 grams of CH4, and we're changing that into moles. So we put the molar mass on the bottom, which is 16.362 grams, and we put 1 mole on the top to balance that. Now, molar ratio between methane and H2O. So if we look at our balanced equation, there is 1 mole of CH4 for every 2 moles of H2O. So now we're in moles of H2O, and we need to find grams. So we put 1 mole of H2O on the bottom and 18.016 grams of H2O to balance that. So if you plug all of this into your calculator, you will get 1101.1 grams of H2O. 500 grams has 1 sig fig, so the 1 does not round up, which makes your answer 1,000 grams of H2O.
Okay.
Okay, so for practice problem 1, what mass of acetylene, C2H2, will be produced from the reaction of 90 grams of calcium carbide, which is CaC2, with water in the following reaction? So try the problem on your own and we'll review the answer. Okay, so we start with 90 grams of CaC2, which is what the problem tells us, and we need to go to moles of CaC2. So we use our molar mass from the periodic table, which is 64.1 grams, and we put 1 mole of CaC2 on the top. So now that we're in moles of CaC2, we need to use molar ratio to get to moles of C2H2. So for every 1 mole of CaC2, there's an understood 1 there, there is 1 mole of C2H2. And our moles of C2H2, our final step is to change that to grams. So we start with 1 mole of C2H2 on the bottom, and we need our grams on the top. So if you look at your periodic table, your grams of C2H2 are 26.036. So if you put this all into the calculator, you should get 36.55 grams of C2H2. And if we look back at our problem, 90 has 1 sig fig. So your 6 rounds up, and your final answer is 40 grams of C2H2.
Okay.
Okay, for our second practice problem, calculate the mass of lithium required to produce 59.5 grams of lithium fluoride. So try the problem on your own, and we'll review the answer. Okay, so we need to start with grams of lithium fluoride, which the problem told us is 59.5, and we need to go to moles of lithium fluoride. So we use our molar mass from the periodic table, 25.941 grams, and we add 1 mole on the top to balance that out. Now we go from 1 mole of lithium fluoride to our molar ratio. We have 2 moles of lithium fluoride for every 2 moles of lithium, because that's what we want to end up with our final answer. So now that we're in moles of lithium, we need to find grams of lithium. So for every mole of lithium, we have 6.94 grams, and again, that you can find that with your periodic table. So if you plug that all into the calculator, you get will be 15.9 grams. And if you look back at the problem, your number is 59.5, which is 3 sig figs. So your 9 rounds down because the answer is 9.1, and your answer stays at 15.9 grams of lithium. Exam review for stoichiometry.